Hi everyone, and welcome to this week's video. Today we're going to go over some more inference rules and go over some practice problems. So our first inference rule is the negation elimination. So this one's pretty much if you have a negation, A and then A by itself, then you have a contradiction. So then you can put the rule negation elimination from these two lines. And the two opposites pretty much, not A and A, can be anywhere within the proof. Doesn't need to be right next to each other in order for you to apply this rule. And we'll see why that's helpful later in some practice problems. Okay, our next rule is the negation introduction rule. So this one involves a subproof. You have to assume A or the positive version. If you find a contradiction somewhere down the line, then you can automatically conclude that not A. So if assuming A gets me something somewhere wrong or somewhere that's contradicting, then I can say that not A is true, not A is the case now. And that's through negation introduction from the whole subproof, so I through J. The indirect proof is pretty much the opposite. I can assume not A, find a contradiction somewhere down the line. Any other letters can be contradicting themselves, and then it would lead me to say, okay, A is the case. So if I assume not A, and that's wrong, then I get to say, okay, the opposite of that is right, pretty much. And then I have to cite it using, again, the subproof I through J. And the explosion rule is pretty much if you have a contradiction, then you automatically get to literally add anything that you want using the explosion rule. And we'll see why that's helpful later down the line. Okay, so I wanted to just lay out all these rules for you guys just to see what's going on and where subproofs are needed, because that was definitely the most confusing thing for me when I was taking the class. So our first rule is the disjunction introduction and the disjunction elimination. Elimination is where you're going to need the subproof. If you see a disjunction within your premise, then you know right away you're most likely going to need a subproof. Okay, so whenever I want to use the conditional elimination, if I have all my pieces, I don't need to start a subproof. But if I don't have the pieces to get rid of the conditional, or I want to add a conditional, I'm going to need a subproof. That would be a reason for me to open a subproof. Similarly to the biconditional, if I want to add a biconditional, I see that in my goal, like the main connective is a biconditional or conditional, then I could just add a subproof with the left and the right side and take care of that using the rule. And if you want to review that, take a look at the last video I posted last week and the one before it to really get a good picture about how these rules are working. So also the easy one, I missed that one. That one pretty much is the easiest one. You could just introduce if you've got two atomic sentences, you can just introduce the conjunction, or eliminate if you've got them together. You can just take them apart. For the negation introduction, which is what we learned today, this one also requires a subproof. The negation elimination does not, because you pretty much, if you just find two contradicting pieces, then you just right away put that upside down T next to it, and next to it you put the negation elimination. But with this, you have to assume the positive A, and then it'll lead you to negative A with using the contradiction, and that's how you add that negation. That's how you introduce the negation. You have to use that subproof. If you assume positive A and it leads you to a contradiction, then you're able to add the negation. The opposite of that is the indirect proof, where you assume the negation in order to get you to the positive version, right? Or to like A. So you assume not A and it gets you to A using the contradiction, but it has to also involve a subproof. And also, the explosion rule is helpful for when you see a contradiction and you can just add whatever you want. Okay, so our general recipe, this is from lecture. This is very helpful for me also when I was taking the class to just kind of have a checklist for me when I'm going through all these problems, because sometimes it just kind of gets convoluted. So is there a disjunction in the premises? If you see that, then you know you might need to do disjunction elimination, where you need a subproof. You need two subproofs in that. Do you need to eliminate anything? You don't need any subproofs for that, but you just need to have all the relevant parts. Do you need to introduce anything? If you do, then you're going to have subproof. Do you need an indirect proof? And so on. So we'll take a look using our general recipe to go through all of these relevant steps. Okay, so our first problem is pretty much prove J arrow not J concludes or is therefore not J. So that's our proof. This is our premise, and we're trying to prove not J. So right away, let's actually go back. Let's actually go through our rules. So the first rule is there a disjunction? No. Okay. Can we eliminate anything? Well, we don't have the relevant part. If we had a J somewhere in our premise, if we had a second premise with J in it, then we can just take out not J and we'd be done. But that's not the case. Well, can we introduce anything? And what would be the justification for introducing it? Well, we want not J. What could we introduce to get us to not J? Well, there's no connective other than the negation. So right away, I know I'm going to need to do what? I'm going to need the negation introduction. Okay, so that's my reason for introducing that. And so we know the rule for negation introduction. You assume the positive to get you to the negative. Let's do that. Let's do positive J, right? And we're trying to get to negative J, but let's take a look at what we could use with the premise above. So now that I have my J, then I can automatically get rid of the conditional and get my not J. So I got my not J, and using the conditional eliminations from line 1 and 2. We're familiar with this. This is the easy part. Okay, now what? How could I get out of this proof? I need to do something to be able to get out of this subproof and finally prove. I can't just stop there, pretty much. I can't just finish it off at not J. I have to get out of the subproof. So my justification for doing that, remember, is you have to show that there's a contradiction. And we've got that. We've got J and not J. That's a contradiction using lines 2 and 3. And you just label that negation elimination. So using that, now I'm ready to get out of my subproof and show that I've proved that from J I got not J, and that's the exact thing I'm trying to prove, not J. And using lines 2 through 4, I introduced a negation, and I went from J and I put a negation on it, and that's how you do it. That's a negation introduction. Okay, if that wasn't quite clear, let's take a look at another problem, and I hope it's more helpful now. Okay, so we have this problem. Say we have Q arrow, Q and not Q, and we're trying to prove not Q. So again, our main connective is not a conditional or biconditional, so we know we're going to have to introduce something because we obviously, there's no disjunction, we can't eliminate anything, so we're going to have a subproof. And since the main connective here and our goal is a negation, we're going to have to use the negation introduction. That's it. If your main connective here was a conditional, then you do conditional introduction. If your main connective here is biconditional, then you're going to do biconditional introduction. And so going off what my goal is, I'm going to do the rule for the negation introduction. So I know that I have to start with the positive, so it's just Q in this case. And then I can use, now I go back to normal, and I can use my premise. So I know from conditional elimination, if I've got Q, then these pretty much kind of cancel out, and I can get Q and not Q. Okay, now it's easy. I can just do conjunction elimination and take out all the pieces that I want to take out. So I'm going to take out the not Q. And why is that? Because I'm trying to show contradiction. Remember, it's got to go positive, contradiction, negative. So there I have it. I've got Q and a not Q, and I've got the contradiction. And that's using line 2 and 4. And it's called negation elimination. And then from there, I showed that I assumed that having Q gets me the wrong way. It gets me to contradiction. And so then I'm able to go back and say, well, okay, so I can't have Q, so not Q. So it's pretty much a clever way of introducing not Q. And that's how we prove it using this subproof. And I didn't make any of these rules up or any of these steps. These are from the rules that were given, and we're able to do all of these steps. These are also problems from your book. So if you wanted to take a look at more problems, I highly, highly recommend it to really get practice for the homework. Okay, let's look at another problem. We've got P arrow Q, and we're trying to prove not Q arrow not P. Okay, so let's take a look. Do we have a disjunction? No. Can we eliminate anything? We know we need a P in order to get Q out. That's the only way we can eliminate anything. We don't have that. Okay, so what could we do? Well, the main connective here is what? The main connective is the conditional. So let's start off by having a subproof using the conditional introduction. So obviously we know the drill. We start with the left side to try to get to the right side, and that's how we get our proof. Okay, so I started with not Q, that's my left side. I'm trying to get to not P. Okay, so having not Q, does that help me in any way breaking apart my premise? Well, I told you I needed a P in order to get Q, but I have a not Q, and that's not very helpful. Okay, well, I'm gonna have to get even more creative and use some more rules. Okay, so let's see. What could I do? So I'm gonna need another subproof. I'm gonna have to introduce something with the P. So I know there's a negation next to the P, so that's what I'm trying to get. So from a rule that we know from last example, I've got a what, so I've got something, and then it leads me to a contradiction, and I'm able to get the negation of it. So that's exactly, it's the positive. So I have a positive letter, I have a contradiction, and then it gets me to the negation. So that's exactly what I'm gonna do over here. I'm trying to get to not P. So what should I assume to get to not P? I should assume the positive version of not P, which in this case is P, to try to get to not P using the what? So we'll see. So we've got P, right? We assume P, and then right away now I know I can use my premises. I can do P, I can cancel them out pretty much using the conditional elimination and get Q out. Well, now that I have Q, what can I do now? Well, I'm trying to get a contradiction in between. That's how I'm able to come out of that subproof. And the subproof was 4, we'll see. So I have my contradiction, right, from Q and not Q, and that's lines 2 and 4. Okay, so now that I have lines 2 and 4, with the, now I can say not P. Okay, so because I was able to get P leading me to a contradiction, then I can get pretty much not P. Okay, so then now that I have not Q leading me to not P, now I can do what? Pretty much can come out of that subproof. So not Q leading me to, so if we assume not Q, which is the beginning of this subproof, and then we ended with not P, and that's how I'm able to get that from lines 2 through 6. So one more time, we've got 2 subproofs here. We started off from the big picture is P arrow Q. I can't do much with it, so I start off assuming I open up this this for the conditional introduction rule. Okay, so I'm trying to get from not Q to not P. Right, that's my big picture. But along the way, I'm stuck. I need another subproof to help me out. So I assume P in order to get to not P. Okay, so the rule for doing that is through negation introduction, and I know that I'm going to need a contradiction along the way in order to get not P, and that's exactly what I've got, and that's how I was able to exit that subproof through not P. And once I got not P, I was able to even exit that last subproof and get my final answer, which is not Q arrow not P, leading me to my final answer, and I'm done. I'm good to go. I hope that was a little bit more clear. If you have any questions, please email me and let me know. Okay, one more. This one's a hard one. Okay, so we've got 2 premises now, and we're trying to prove Q or E. So let's take a look. What could I break apart? Is there anything is there a disjunction in my subproof, and can I start it right away? Well, yes, but I can't start it right away. And why is that? Because my main connective within that disjunction is a conjunction. So I need to break out the conjunction in order to get to the disjunction first. So great, I've got something to break apart. So let's do that. So I've got P from pretty much conjunction elimination from line 1. And from P, I'm also able to get conditional elimination and get R not R1 out too. So that was great. Using lines 2 and 4, conditional elimination. I can also get Q and R out from the conjunction elimination from line 1. And now I'm stuck. Okay, so what could I do? Oh, I can't eliminate the disjunction right away. So I'm gonna have to do what? I'm gonna finally have to use the disjunction elimination rule. Now that I've got my disjunction. So because there's nothing for me to eliminate, this is the rule that I'm starting off with now. So we know the drill. We know we start off with a subproof. So Q, right, the first part, and we're trying to get to what? We're trying to get to our goal. We're trying to get to Q or E. That's easy. You could just literally plop a Q or E, and you just do disjunction, introduction, line 6, and you're good. That's it for that subproof. So does that make sense? You just need, if you're just trying to add a disjunction, it's super easy. You can just add any letter next to it, and you're good to go. Okay, well, we need our second subproof. We need R. We need our R, and we're trying to get to Q or E. So then R, and then how could we get to R? Like, how can we get to Q or E from here? Let's take a look. Well, right away, when I put down the R, we notice that there's a not R. So that's a what? That's a contradiction. So that's from 4 and 8. And knowing that there's a contradiction there, guess what? I can just literally put Q or E without doing any work other than just using my rule. So I did the explosion rule from line 9 because there's a contradiction, right? So remember, the explosion rule is that if you assume a letter and then there's a contradiction, it's a contradiction, then you can get to pretty much like say anything that you want. That's exactly what happened in this proof. And so then I'm finally, now that I have both sides, I can put down Q or E using line 5, because that's where the first disjunction was at, and then these two subproofs from line 6 through 7 and 8 through 10. And I'm good to go. All right, guys, I hope this was really helpful for you. So just quick, pretty much reminder, just remember your rules. These are most important for you. Have them written down right next to you. It's really, really helpful. And remember to work strategically, like use the guidelines that you're given. Those 4 steps are really, really helpful to kind of like get you thinking about what steps to take. Keep in mind that it's not about memorizing steps. You're not trying to watch this video so you can like do exactly like copy and paste for the homework or anything like that. But it's about understanding how you can use the rules to help you solve any problem on your own, pretty much. And just finally, don't give up. You got this. You have a lot of time tomorrow to finish this. Please start it early. Take time to really get into this, so that way the more time you give yourself, the higher your grade will be. All right, good luck on this homework, and I'll see you next week.